Welcome to Electric Fun. In today's class, we are going to discuss the problem on observable canonical form and obtaining the state space representation. So this is a given transfer function y of z by u of z equals to z plus 1 divided by z square plus 1.3 into z plus 0.4. So for this given transfer function, we have to obtain the observable canonical form as well as we have to represent its state space representation. So observable canonical form, this is a standard representation in state space representation, that is x1 of k plus 1, x2 of k plus 1, so on up to xn of k plus 1, that is equals to 0 0 up to so on minus an, 1 0 up to so on minus an minus 1, this is so on up to 1 0, and this is so on up to minus a1, x1 of k, x2 of k, xn of k plus bn minus an b naught, bn minus 1 minus an minus 1 into b naught, and third element will be bn minus 2 minus an minus 2 into b naught, and so on up to b1 minus a1 into b naught into u of k. And y is written as y of k equals to 0 0 up to so on 1 into x1 of k, x2 of k up to so on xn of k plus b naught u of k. So if it is of 2 by 2 matrix, simply you can write the C matrix as 0 1. If it is of 3 by 3 matrix, simply you can write as 0 0 1. The main difference between the observable canonical form and controllable canonical form, if you observe that, you can easily know. So let us see the main difference over here. So if you observe this minus an minus 1, this minus a1, this is in the last row in observable canonical form, whereas in controllable canonical form it is in the last column. This column has been interchanged to this row. And coming to the B matrix, this was earlier, it is a column matrix in C in controllable canonical form. These both are interchanged. This column has become this row and this row has become as a column over here. Only that is the difference, and remaining everything is same. So, and this standard representation of transfer function is also same. Y of z by u of z equals to b naught z power n plus b1 z power n minus 1 plus b2 z power n minus 2 so on up to bn divided by z power n plus a1 z power n minus 1 up to so on an. This everything is same. This formula is same. Just this column will become this row. This column over here becomes this row, and these two are interchanged. So given transfer function, let us write it as equation 2 and the standard representation as equation 1. We have to compare this both the equations 1 and 2. Since the order here z power n, so here z power n equals to how much? 2. So as it is order is 2, we'll get only a1 a2, and coming to the numerator we'll get b0 b1 and b2. If it order is 3, then we'll get a1 a2 a3, b0 b1 b2 b3. So since here n equals to 2, we get only a1 and a2. We have already seen the problem. Just compare these terms with the given equation. So let us see here, a1 z power n minus 1. Already we have done in the earlier problem. a1 z power n minus 1. So a1, what is n value? 2. So 2 minus 1 is 1. Z power 1 is 1. That is nothing but z into a1. So here also z into a1. So what is a1 value? a1 equals to 1.3. Similarly, second element, what does that become? a2 into z power n minus 2, that is a2 into z power 2 minus 2, that is z power 0. Z power 0 is nothing but 1 into a2. So what is 1 into a2? a2 equals to 0.4. And similarly, in the numerator we do not have any z power n, so b0 value we can write it as 0. And second term is b1 z power n minus 1, that is if you substitute 2, that is b1 z power 2 minus 1, that is 2 minus 1 is 1, z power 1 is z1 into b1. So what is b1 value? So here you can see z into something, that is 1 into something is 1 itself. So b1 will become 1. And next coming to this element, so b2 z power n minus 2. So b2 z power 2 minus 2 is 0, z power 0 is 1, 1 into b2 is b2. So what is the b2 value here? b2 equals to 1. So we have compared both the equation 1 and 2, and we have got the values as a1 a2 b1 b2 and b0. Now we have to represent that in the standard representation, that is x1 of k plus 1 and x2 of k plus 1. We have only order 2, so x1 of k plus 1 you will get x2 of k plus 1. So simply you have to represent 0 and 1 as it is, 0 and 1. You got n value as 2, so minus a2 and minus a1, x1 of k, x2 of k plus b2 minus a2 b0, b1 minus a1 b0 into u of k, and y equals to, it is 2 by 2 matrix, so simply represent 0 into 1, 0 and 1, x1 of k, x2 of k plus b0 u of k. and just substitute the values. So already we have got a1 value, a2 value, b0, b1, b2. Just I am substituting in the above expression, that is 0, a2 value is minus 0.5, 4, 1 minus 1.3, a1 value is 1.3, so minus a1 means minus 1.3, x1 of k, x2 of k, plus if you solve this b2 minus a2 into b0, here I have solved, that you got as 1. Already we have done it in the earlier problem also. Simply just put the values and you solve, you will get as 1 and 1, and y of k equals to simply 0, 1, x1 of k, x2 of k, and D matrix will be 0. So this is how to solve the observable canonical form and representing in the state space representation. If you like the video, please like and share and comment. Thank you.